Welcome back. Now we'll be moving on to chapter 2.5 from the textbook, which is the Cartesian vectors, their addition and also subtraction. So it's going to cover 2.5 and also 2.6, this lecture. Okay, so we're going at the end of the day, you should be able to represent the 3D vectors in Cartesian coordinate, find the magnitude and coordinate angles of the 3D vector, and add the vectors in the 3D space. So this chapter includes 3D because most of the time in your life around you is actually everything is in 3D. So there are many structures or machines that involve three-dimensional. So in this case, remember this power pole? We don't have it in Malaysia nowadays, because most of the time our poles are, our electrical cable is actually underground. But if you go to old towns and all, you can still see these, and you can see the cables being tied. So this pole is actually planted to the ground, and there would be some cables to hold it. So you need to also find the resultant, where you're given FB and FC, you're given the distance. You can use the Cartesian vector to actually find it. Another example would be this what you call radio tower. If you see this radio tower, you also see the similar thing. Okay, if you look here, can you see this 600, 800 and also 400? They all are dropping down at different coordinate, different angles. So it looks very complicated to find the resultant, but it's kind of like simple when you use Cartesian, when you understand the concept of Cartesian vector. So don't worry much. So most important is that this is how the representation is. You take your right hand, you curl it, and you point your thumb up. So the place that it points up will be the z-axis. Your inner arm will be your y-axis, and your outer part here is your x-axis. Okay, now if you see that I is represented in x-axis, j is representing your y-axis, and k is representing your z-axis. So all this direction is your positive direction. So anything that is opposing the movement, opposite in the opposite direction. So it means if let's say you have a vector this side, so this would be negative I. You understand what I'm saying? So if this y is this side positive, so anything that's opposing this side will be the negative of y, or you can say negative j, and anything that's downward, that would be your negative k. So that is how you interpret this. Okay, so that's the direction. Okay, moving on to the next slide. So we're going to look at the summary of formulas. I will go back to your textbook because your textbook has summarized it very nicely for you to actually understand, and I will come back to the lecture note shortly. So this is your Cartesian vector from your textbook. It's the page from the textbook. So if you write, it will be ax plus ay plus az. Of course, it is not something that you can just add on. Remember, because this is vector. And then we have I, j, k, that shows your positive directions of your x and y and z axis. So how do you represent? You have a, which is the resultant, which is the blue. Okay, and then we have the axi. So ax would be a numerical value. I just shows the direction. Ayj, once again ay is numerical value, and j just shows the direction. And azk, so k just shows the direction. Now how do you find the magnitude? So magnitude is very simple. You just take the ax from up here, square it, plus ay square plus az square. So this is numbers. You square root them, you get the a value, the magnitude. Now how to find the angle? This is kind of tricky. I want you to pay attention. Want you to pay attention. If you look here, okay, enlarging it so that you can understand. Okay, so we have here coordinate direction of alpha, beta and gamma. Alpha represents the x, the angle between the resultant and the x-axis. Now let's look at this alpha here. Can you see this drawing here? Can you see how it's actually extending from this blue line to the x-axis? all the way, this whole thing. Can you get that? So that is your alpha. Yeah, that is your alpha. So alpha will be anywhere in between 0 to 180. So if it goes beyond that, it will fall onto the negative region. That's all. Yeah. So it has to be 0 to 180. Now, if you take your beta, look at this beta. Okay, this beta is actually extending from the blue line right up to the y-axis. And then you have the gamma. Gamma is extending from the blue line to the z-axis. Yeah. So this is your alpha, beta, and gamma. Cos alpha is ax, magnitude, yeah, ax divided by resultant a. So you can get your alpha, beta, and gamma. Since that this is vector, it's very important for you to actually show the direction. Okay. Now this next page actually gives the unit vector. Yeah, unit vector. Okay, how do you find your unit vector? So unit vector would be ax divided by a. Now what is this a at the bottom here? That would be the resultant, the magnitude that you have found. Yeah. So ax would be the force that is in x direction. Similarly, ay over a j and az over a k. Okay, it may be a bit confusing for you to look at this blue box. Yeah, it's okay. When you calculate, you will understand what is finding the unit vector. Okay, so now remember also, just now you have alpha, beta, gamma, right? Okay, sometimes some question will just give some missing angles, and probably they will just forget to give the beta or purposely don't give the beta. So what do you do? Remember formula 2.8. Yeah, this is a very important formula, always being tested in final exam. If you forget this formula, you may not be able to answer the question. So what we have here, cos square alpha plus with cos square beta plus with cos square gamma equals to 1. So if you have a missing gamma, then you can actually get cos square alpha, cos square gamma minus with 1, and then you can inverse cos square to find the beta. Yeah. Okay. So this is how another way of representing your ax, ay, az. In another way, ax is actually a cos alpha, ay is a cos beta, and az is a cos gamma. Yeah. So this is how you find the vector. Okay. So going back, yeah. So we have the addition of the Cartesian vector. This is very simple. Yeah. I'll just teach you the theory behind this, and then we will look at a calculation. So if you even have a, b, a, yeah, you have a and then you have b. So what you do, you break this a into ax, ay, az. And then you break the b into bx, by, bz. Okay, and then you add all the x together, or the i's together, and you add all the j's together, and you find all the k's together. So you put them together. Let's look at this formula. Can you see this? Ax plus bx, I. So I actually shows the direction that this numbers ax and bx is in the x direction. And then you have ay plus by, which is j. Yeah, this shows that ay and by is actually in the j direction. And then we have az plus bz, which is in the k direction. So this is how you actually put them into their direction. Okay. So with that, so let's go back to the lecture note. Okay. Here. Okay. So let's look at this. Sometimes 3D vector information is given as magnitude and coordinate of direction angles, or sometimes it can be projection angles. So you should be able to represent it into I, j, and k Cartesian form. Yeah. So let's solve an example. Yeah. I'm going to go to the textbook example because textbook example is more complicated. The examples here, you can just solve it by yourself, and we will actually proceed to the next chapter in the next lecture. But before that, let's do a question. Yeah. So let's look at example 2.8. Okay, so we have example 2.8. So what does example 2.8? Express force F in Cartesian vector. So we have the 100. We're going to express 100 in x, y, z axis. Or you can just put your I, j, k axis. Yeah, I, j, k axis. So this is a bit tricky, yeah, because yeah, let's look at it. It's okay. Yeah. So the easiest thing to see is that, okay, observe this. We have 100 at an angle of 60 from where to where? 60 is actually between, so between x, you see, it's between here and here, this plane. The 60 is actually in between this plane here. Can you understand it? So which means this opposite will be the sine of 60, correct? So that's why it's 100 sine 60 is 86.6. Settle. Yeah, 86.6. So you have settled for the FZ. Okay, no problem. Okay, so FZ is settled. That is the final answer for FZ. I'm going to highlight the final answer for FZ because they want you to put it in X, Y, Z. Right. Okay, so that's settled. Now let's look at this next working. Okay, so if you drop, just imagine mentally that you are dropping this line. You're dropping the 100. Yeah, you're dropping it flat on this plane here. Okay, you're dropping it flat on which plane? This plane. Can you see this plane here? Yeah, you're dropping it flat on the plane. So when you drop it flat on the plane, you can see this drawing. Oh, I have to, when I drop the thing, the thing is not accurate. So let me just redraw this. Can you see? When you drop, it is something like this. That's 100. In the process of dropping, this one is just not 100. You have generated a new number. That would be 100 cos 60. Yeah. So this line now, which is flat on the ground, yeah, it is 100 cos 60. So we call this f prime. Okay, we call this f prime. Okay. So now it is flat. It is flat on this plane. It's flat on this plane. Can you imagine that? Yeah. Okay, but that doesn't solve. You need to find fx and fy. So where is fx? Fx is here and fy is here, correct? So fy is going to give you in a negative direction because in the opposite side. Yeah. Okay, so hold on to that. Okay, now let's solve this. Okay, you can understand this. Now it's in that plane. Okay, now we're going to solve. I'm going to use another ink here to just make you understand. So when you bring to x direction, so it is stated here that the angle here will be 45 degrees. So you close the armpit. 100 cos 60 cos 45. 100 cos 60 cos 45. Yeah, 100 cos 60 is 50. So 50 cos 45, you get 35.4. Okay, so it means your double cos, twice your cos. No, first one is to drop it down and then next to close it to the x direction. So as for sine, if fy is cos, okay, of course the opposite will be sine. So you have 35.4 as well. Oh, that looks like a nice number. Almost everything gives almost a similar number. So what's the answer now? Fz is 86. Yeah, and then we have your fy, which is 35.4, and then we have the fy, which is 35.4. Now let's look at fy. Fy is very unique. Why? Because it has a negative. Actually, what happens in that? Remember just now, you close this towards here. This is an x which is in positive direction. Where else? If you drop this, close this here, which is 100 cos 60 sine 45, it's actually pointing in the negative of y because this side is positive of y and the opposite side will be negative of y. Now that's the reason why it got the negative value. Okay, I hope you can understand. So now let's check the answer. So what is the magnitude of all this? What is the magnitude of this resultant? Okay, what you did was to resolve it, to break it up into x, y, z component, which you have done. Now let's check our answer, whether what we have done is correct or not. So you find the magnitude again. You square this, square this, square this. So we get 100. Isn't it the same? Yeah, because the original was 100. So that's how to check the answer. Now, if the question asks you to represent the value in unit vector, yeah, in unit vector, so what do? Remember the 35 that you've got? 35 divided by 100. That is for the 0.354 for the I. Yeah. And then we have 35.4 negative divided by 100. It gives you negative 0.35. Likewise, you repeat 86.6 in the form of unit vector. Okay. The F down here will be the magnitude, which is 100. So fx, fy, fz is the value that you have actually calculated, which is all these three values. Okay, so that is to calculate the unit vector. So what do you do with the unit vector? You can actually find the alpha, beta, and gamma. Yeah, you inverse cos of the I unit vector, you get 69.3. You remember the formula from here? Okay, let's go back, revisit the formula. Yeah, we have done this in the textbook, isn't it? Huh? Okay, let's revisit the formula. Okay, you remember this? So what we have? You have unit vector, right? Yeah, ax over a. Okay, ax over a, ay over a, az over a. That is the unit vector. Now the angle, what is the angle? Can you see that? Ax over a is the angle, inverse cos. So you get the alpha. You inverse cos the beta of ay over a, you get the beta. So that's what's happening here. Okay, so press your calculator. Now you will get the value. Okay, you get the value inverse cos of 0.354 here to here. You get 69.3. Now let's look at this. So what we have here? 69.3, and then this is 30. Okay, you press your calculator, you get all these values, 111. Okay, now it's unique, right? Okay, you see this, it is within 90. This is also within 90. But this has exceeded 90, which means it falls in the negative of y. You understand or not? Yeah? So you see the limitation of this x to be in the positive region is here to here, in between these two lines, right? Yeah? From here to here is 90. This is a bit of imagination. Of course, when you get a negative value press here, you will get a bigger number. So that bigger number will actually be at the back here. Yeah. So that's how it is. This is a bit of imagination. You have to visualize it. Yeah. So here we have 69.3. Okay. So I hope it's the explanation is clear. If you don't have, if you have any issue, you can actually meet me during the consultation hours, and you can ask me the question. Okay. So with that, I'll meet you in the next video. Thank you.